Okay, next question. The wheel of a motorbike has a diameter of 50 centimeters and accelerates from 4 radians per second to 10 radians per second in 10 seconds. Now we're asked a few questions. The angular acceleration, the angular displacement, and the number of revolutions. So I always like to start with a drawing first. What do we have? We have a motorbike wheel and it has a diameter. Here's my motorbike wheel. Lovely motorbike wheel. Has a diameter of 50 centimeters and accelerates from 4 radians per second to 10 radians per second in 10 seconds. Now, the first one is to calculate the angular acceleration of the wheel. So we know in linear motion, V is equal to U plus AT. Final velocity, initial velocity, acceleration, and time. So if I write it for angular, it would be omega 2 is equal to omega 1 plus angular acceleration multiplied with time. And I know the final velocity was 10 radians per second. The initial was 4, and they told us what the acceleration was. Do we know what the acceleration is? No, because we're going to calculate the acceleration. So we want to know what alpha is. But we know what the time is, 10 seconds. So this will be, if I simplify it, alpha will be equal to 10 minus 4 divided by 10. So let's get our calculator out. Calculator on. Let's clear this away. Previous calculation. 10 minus 4 should be 6 divided by 10 gives us 0,6. So alpha is equal to 0,6 radians per second. Okay, so that was number 1. Let's have a look at the next question. The next question says, calculate the angular displacement of the wheel in radians. Okay, so displacement, we think of S immediately. So if we write it in a linear form, S is equal to ut plus a half at squared. Let's just erase that. That should be a square. The other displacement that we know, a formula with displacement, is v squared equals u squared plus 2as. Now let's have a look at the information we have. Do we know the time taken? Yes, 10 seconds. Do we know the acceleration? Yes. Do we know the initial? Yes. So we can calculate displacement. So the first formula is valid. Let's look at the second formula. Do we have the final velocity? Yes. Do we have the initial velocity? Yes. Do we know the acceleration? Yes. We want to calculate S. Both formulas are valid. So let's test with both. If we get the same answer in both, we know our answer is correct. In a test or exam, stick with one formula and get your answer. Okay, so for the first one, if I have to write it for angular displacement, it would be theta for the angular displacement is equal to omega 1 times time plus a half alpha t squared. Let's write alpha nicely. It's an alpha. So we have omega 1, which is the initial, which was given to us as 4 radians per second, and this is 10 plus a half. We've just calculated the acceleration, which is 0,6 times 10 squared. Okay, let's bring up the calculator again. Let's move it over so we can see what we are calculating. So for the first one, it would be 4 times 10 is 40. That we know, we don't need a calculator for that. 10 squared is 100. 100 times 0.6 is 60. We can confirm that. 60 times a half is 30. And we want to add the two together, and we get 70 meters. Well, not meters, 70 radians. Okay, let's do a test. I'm going to just change the color. This is the test. So we want to use v squared equals u squared plus 2as. So if I write this, this would be omega 2 squared is equal to omega 1 squared plus 2 alpha angular displacement. So if I make omega the subject of the equation, that would be equal to omega 2 squared minus omega 1 squared, all divided by 2 times the acceleration. So that would give me, the final velocity was given as 10 minus 4 divided by 2 times the acceleration. Plug that into my calculator. Let's see if we get the same answer. I think we should. Test it on your calculator also. So 10 minus 4 is 6. 0.6 times 2 should be 1.2. And we want to divide them. Oh, but that's wrong. What did I do wrong? Did you spot my mistake? I forgot to square them. It's 10 squared minus 4 squared. Remember, write down all the steps. Don't take chances. Let's do it again. 10 squared is 100. 4 squared is 16. Minus the 2 from each other is 84. Divide by 1.2. 70 on the dot. Okay, so you see, we could use either formula, 70 radians, and you can choose to use either one. Okay, that was quite good. The last question that we have to do is we're asked to calculate the number of revolutions completed by the wheel during this time. So let's choose a nice color here again. I think we'll stick with the blue. So number 3, the number of revolutions completed. What do we know? We know that the wheel has completed 70 radians. That's all we know. What else do we know? A wheel is a circle. So if I rotate once, how many radians is one revolution? One revolution is 2 pi radians. But I've done 70 radians. So I want to know how many revolutions have we completed on the wheel. It's just a straightforward ratio. But what else do we know? I can say that n times 2 pi, the number of revolutions times 2 pi, is equal to 70. So n must be equal to 70 divided by 2 pi. And if we do that on our calculator, call up the calculator again. Here's the calculator. Oh, look, 70 is still here. 2 times pi, divide. Oh, it's a fraction, 70 over 2 pi. Let's get a number here, a numeric value, 11,14. So this has completed 11,14 revolutions. Done.